Hello, this is the audio reading for Lesson 2 called Earth's Interior. I do not read all of the words, but I will skim through most of it for you. Inside Earth. Deep inside Earth, our planet is constantly changing. Dr. Samuel Mukasa, a geochemist at the University of Michigan, studies some of these changes. He examines rocks in Antarctica that have been brought up to Earth's surface by magma. When he examines these rocks, he looks for elements that occur only in small amounts. These elements can offer telltale signs of progress occurring near the boundary between Earth's crust and the mantle, or even at deeper levels. By studying rocks at Earth's surface, Dr. Mukasa is helping us understand Earth's interior. So just like inside of the Earth and inside of your body, there's different elements in there. We are going to examine those today. How do geologists learn about Earth's interior? Processes that affect Earth's surface are often a result of what's going on inside. But what's inside the Earth? This question is very difficult to answer because geologists are unable to see deep inside Earth. But geologists have found other methods to study the interior of Earth. Geologists have used two types of evidence to learn about Earth's interior: direct evidence from rock samples and indirect evidence from seismic waves, kind of like X-ray vision. And the direct evidence is actual materials. Turn your page to 9. Oh, just kidding. Turn your page to 11. Evidence from rock samples. Geologists have drilled holes, and they drill it deep in the earth, and we're talking about kilometers. In addition, volcanoes sometimes blast rock to the surface from depths of more than 100 kilometers. So we get evidence from the rocks that come out of the volcanoes. These rocks provide information about Earth's interior. In laboratories, geologists have recreated conditions inside the Earth to see how rock behaves. Evidence from seismic waves. To study Earth's interior, geologists use indirect method. When earthquakes occur, they produce seismic waves. So like vibrations, we can measure the vibrations. The speed of the waves and the paths they give geologists clues about the structure of the planet. That is, the path of seismic waves reveal areas inside Earth where they make up or form material changes. To better understand how seismic waves, we can reveal Earth's interior. Look at how the paths of ocean waves reveal the island shown. So they're flowing this way, and then they hit a bump, and they go out and around. Think of the sonar that whales use and dolphins use. We're going to turn our page to 12. What are the features of the Earth? So this is the important part of the chapter. Today, scientists know that Earth's interior is made up of 3 parts: the crust, the mantle, and the core. Each of the Earth's layers cover the layers beneath it, much like the layers of an onion. The 3 main layers of Earth are the crust, the mantle, and the core, and they vary greatly in size, composition, temperature, and pressure. So even though an onion has all the same material in each layer, the Earth does not. The materials are different, the temperature, how hot or how cold it is, the pressure. If it's a liquid, it's going to be a different pressure than if it's solid rock, and the size. So we'll look at that as we move forward. Although each layer of Earth has its own characteristics, some properties apply throughout all of Earth. For example, the deeper inside the Earth, the greater the mass, so more compact the rock is from the pressure on top of it. So pressure is a result of the force pressing on the area. Think of somebody putting pressure on your shoulders. That's the pressure that we're talking about. So the harder they push and the heavier they push down, the more pressure you will feel. The deeper down inside the Earth, the greater the pressure. Think of your ears like this diver on the bottom. If you ever went down to the bottom of the pool, the pressure gets to be a lot on your eardrums. The mass of the rock that presses down from above affects the temperature inside the Earth. The temperature inside the Earth increases as depth increases. So as you go down inside the Earth, it gets hotter because there's liquid metal melting and burning in there. That's the lava that comes right out of the volcano. It's just hiding inside the earth. Just beneath Earth's surface, the surrounding rock is cool. So the ground, the crust that we work on and a little bit under us, it's not very hot. And you know that because you can walk outside without shoes on. We're not going to get too much in depth because it gets a little wordy as we go, so we'll just flip it. So just remember there's crust, mantle, and core. We will go to the crust. So we're going to talk about the crust a little bit. This is the part of the earth that you walk on. The crust is a layer of solid rock that includes dry land and the ocean floor. So underneath the ocean, of course, there's land, and we're talking about that. So all of the surface land. The crust is much thinner than the layers that lie beneath it, so it's very thin. It is made up of basalt. It's a dark, fine-grained rock, and it's made up of granite. The rock is usually a light color and has coarse grains. So I'll read through these 3 paragraphs kind of quickly. The main elements in the crust are oxygen, silicon. The crust is much thinner than the layers beneath it. In most places, the crust is between 5 and 40 kilometers thick. It's the thickest under mountains. Of course, because the mountains are nice and thick and high like this compared to the level like this. The crust that lies beneath the ocean is called the oceanic crust. The composition of the oceanic crust is nearly constant. Its overall composition is much like basalt, with small amounts of ocean sediment on top. Basalt is a dark, fine-grained rock. This would be basalt, the oceanic crust. Continental crust, the crust that forms the continents containing many types of rocks. So unlike oceanic crust, its composition varies greatly. It's like all the crumbs of the earth all balled up, just like that. Think of your Chips Ahoy cookie, all those chunks stuck together. So unlike oceanic crust, its composition varies greatly, but over the composition of the continental crust, it's much like granite. So granite is this rock. It has light color and has coarse grains. Both granite and basalt have more oxygen and silicon than they have any other element. So that is that. The crust is the Earth's outer layer of the Earth. It tells you how thick it is up here, between 5 and 40 kilometers. We're going to talk about the mantle. The mantle is about 40 kilometers beneath dry land. The rock in the Earth's interior changes, but there contains more magnesium and iron. The rock below the boundary is solid material of the mantle, a layer of hot rock. The mantle is made up of rock that's very hot, but solid. Scientists divide the mantle into layers based on the physical characteristics of those layers. The mantle is nearly 3,000 kilometers thick. The lithosphere is the uppermost part of the mantle. It's a brittle rock, like the rock of the crust. But the crust and the uppermost part of the mantle are strong, hard, and rigid. So geologists often group the crust and the upper mantle into a single layer called the lithosphere. So this will be your lithosphere. Shown in figure 4, which is down here, right there. The asthenosphere, below the lithosphere, the material is hotter and under more pressure. As a result, the part of the mantle just beneath the lithosphere is less rigid than the rock above. Over thousands of years, this part of the mantle can bend like a metal spoon, but it's still solid. If you kicked it, you'd stub your toe. The soft layer is called the asthenosphere. The mesosphere, beneath the asthenosphere, is the mantle is hot but more rigid. The stiffness of the mesosphere is the result of increasing high pressure. This layer includes a region called the transition zone, which lies beneath the asthenosphere. It also includes the lower mantle, which extends into the core. So they are talking about part 1, part 2, part 3. Okay? Turn your page. The core. So this is the core. There's 2 parts of the core. There's the inner core, which is a solid, and the outer core, which is molten metal. So that hot metal here is making this part here warm. The core below the mantle lies Earth's crust. The core is made mostly of metals, iron and nickel. It consists of two parts, a liquid outer core and a solid inner core. The outer core is 2,258 kilometers thick, and the inner core is a solid ball. Its radius, which you should have learned in math the other day, so from the center to the side, it's 1,222 kilometers. The total radius of the core is 3,480 kilometers. Too many numbers, insignificant information right now, so don't worry about those. We will just know that there's two parts. The outer is liquid, the inner is solid. Earth's core occupies the center of the planet, so it's not empty in there. Outer core and inner core. The outer core is a layer of molten metal surrounding the inner core. Despite enormous pressure, the outer core is a liquid. The inner core is a dense ball of solid metal. In the inner core, extreme pressure squeezes the atoms of iron and nickel so much that they cannot spread out to become liquid. Currently, most evidence suggests that both parts of the core are made of iron and nickel, but scientists have found data suggesting that the core also has some oxygen, sulfur, and silicon. Very cool. If you want to, these are your words. You can put these words in here for the outer core, the inner core, or both. If that's an activity that you would like to do, you're welcome to do that. If you love math, you're welcome to do this too in your math book. Earth's magnetic field on page 16. The core and Earth's magnetic field, right? Because we're talking about metal, and metals can be magnetic. Scientists think that movements in the liquid outer core create Earth's magnetic field. Because Earth has a magnetic field, the planet acts like a giant bar magnet. We have the North Pole and the South Pole, right? Earth's magnet fields affect the whole planet. To understand how magnetic fields affect an object, look at the bar magnet shown on figure 6. Figure 6, I think, is probably on the next page. Oh, the previous page. Nope, just kidding. We will find figure 6 in a moment. If you place the magnet on a piece of paper and sprinkle iron fillings on the paper, the magnet filings will line up with the bar's magnet. If you could surround Earth with iron filings, they would form a similar pattern. When you use a compass, the compass needle aligns with the lines of the force of the magnetic field. These lines meet at Earth's magnetic poles. So the needle points to Earth's magnetic North Pole, which is at the same location as Earth's geographic North Pole. Very cool. And then this was the model that they were talking about on there. Filings go here and all over. And so this is our North Pole and this is our South Pole. That's our magnetic field there. That is it for this chapter. You are going to use your book to answer the quiz tomorrow. I will include some of the review on it so that you can have some of the answers on there. You will have that assignment in Schoology for tomorrow. If it's fresh in your brain and you want to get it done, go ahead and move forward. There's just a 10-question quiz that goes with it. Make sure you submit it to me when you're finished. And on Wednesday, we will watch a video. And Thursday, we're going to do a fun little activity. So you guys are welcome to move ahead to see what assignments are set for you. And we're going to have a little fun craft activity on Thursday. And we will find something fun for Friday. I'll let you guys make up on some of your work. So if you need breaks, take breaks. If you need to pause videos, pause videos. If you need to replay them, please do the above. Good luck and thanks for all your hard work, guys.